Welcome to Better Health Guy Blogcasts, empowering your better health. And now, here's Scott, your Better Health Guy. The content of this show is for informational purposes only and is not intended to diagnose, treat, or cure any illness or medical condition. Nothing in today's discussion is meant to serve as medical advice or as information to facilitate self-treatment. As always, please discuss any potential health-related decisions with your own personal medical authority.
Hello everyone, and welcome to episode 206 of the Better Health Guy blogcast series. Today's guest is Elliot Overton, and the topic of the show is thiamine and beyond. Elliot Overton is a nutritionist based in France and the founder of EO Nutrition, a private nutritional practice. His primary research area focuses on the clinical use of high-dose thiamine, or B1, for managing chronic diseases. Elliot frequently lectures and speaks at educational events aimed at practitioners, helping to broaden the understanding and application of thiamine in clinical settings. He also runs the YouTube channel EO Nutrition and manages the website thiamineprotocols.com, which provides clinical protocols on high-dose thiamine that have been used by over 3,500 individuals, many of whom are healthcare practitioners treating their patients. Furthermore, he is a co-founder and CEO of Objective Nutrients, a nutraceutical company specializing in excipient-free thiamine derivatives and related supplements. Elliot's overarching aim is to increase awareness about the benefits of thiamine through education and advocacy, striving to make this knowledge accessible to both practitioners and to the general public. And now, my interview with Elliot Overton. I have listened to many of Elliot Overton's educational videos and have used some of the products he's formulated in the thiamine realm. Usually I joke that you have to slow his videos down to about half speed to keep up with him, and today I'm going to see if I can keep up with him in this discussion. As a reminder, I had Dr. Chandler Mars on the podcast in episode 163 to talk about thiamine deficiency disease, so you may want to refer back to that episode as well. Thanks for being here, Elliot.
You're welcome. Thanks for having me on.
So what drives your passion for the work that you do today? Did you have your own health journey with chronic health challenges that was a catalyst for your work? And what were the keys to your own healing? And then extending on that, what drew you to then become an expert on thiamine?
Kind of just happened by chance, I'll be honest. I think it's born out of a curiosity. I just want to understand how things work. And, I've always been curious. I just stumbled across an interest in nutrition, let's say. And trying to figure out how things go wrong, with relation to disease. That's really what it is. I think it's primarily just a curiosity and wanting to find out how to fix problems. What brought me here? Well, I had some minor health issues. I haven't had anything like, Lyme disease, chronic fatigue syndrome, anything severe. But I did used to have digestive issues. Started after I went on a long backpacking trip through India and developed some pretty severe gut infections. And I was left with what you'd probably call post-infectious IBS or SIBO. And so it took me several years to figure out how to address that. And some of the things that I did in myself, or that I found successful in myself, I didn't understand why they worked. And so some of the things that I went on to learn, particularly about vitamin B1, that came in handy because it was kind of born out of the curiosity of wanting to understand how certain things were working in my own case, and then later or subsequently in clients that I was working with.
So let's build then on the topic of SIBO. My perspective for quite some time has been that killing a bug is not the way out of SIBO, that we really need to look at the vagus nerve, the autonomic nervous system, bile flow, the migrating motor complex. And then I think there may be a place for some microbial support, but I think for most people, it's too much the focus of how they approach recovering from SIBO. You have a great video that outlines a 5-step process that I really resonate with, where step 1 is more the dietary piece, either low FODMAP or the specific carbohydrate diet or carnivore, trying to remove as many of those irritants like oxalates as possible, maybe fasting to support the migrating motor complex. Then in step 2, you're working on fixing gut motility, focusing on the vagus nerve and the tonification of the parasympathetic nervous system, which I think is so critical. Step 3, you start getting into more digestive function support with hydrochloric acid, bile support, both of those being antimicrobial. Step 4, you talk about the methodical use, and I think that's critical, the methodical use of antimicrobials, including spore-based probiotics, which I love. And then you also talk about L-reuteri as a yogurt. And then finally, in step 5, repairing and healing the gut. So looking at things like colostrum or bovine immunoglobulins, butyrate, lactoferrin, those kinds of things. And then I generally, if someone has a lot of gut issues, I also tend to think about, are they living in mold? Do they have mycotoxin exposures? Do they have sinus overgrowths or dental infections maybe that are kind of constantly seeding the gut as well? And I think your model is really thoughtful. In fact, I encourage people to go. I spent a lot of time looking at some of the videos on your site, and they're all very, very helpful. So I encourage people to go check those out as well. But talk to us about the role of thiamine in SIBO, which is something that I think I learned about from you in the last year or two. So how often do you think thiamine is a beneficial tool for GI issues? And is it primarily working through supporting the vagus nerve, or are there other mechanisms by which thiamine may be helpful for people with small intestinal overgrowths?
Okay, a lot to unpack there. To give some context, so the concept of using thiamine, a B vitamin, for chronic digestive issues is somewhat controversial, and there is really only a handful of people probably in the entire world who know about this, or at least in the English-speaking world, or at least there was until a couple of years ago. So it's not a very well-known concept, and I stumbled across it by accident. Essentially, so you excellent detail describing what I had recommended in my videos for treating SIBO. And that was really born out of the experience of going through the functional medicine training programs. I did 2 of the big ones. I didn't do IFM, but I did A4M and FMU. And the general treatment for chronic digestive issues, although it is far way and beyond what you would find in conventional medicine, it still is all too often ineffective. And I feel as though there is a perhaps understandable, although I don't think very accurate, hyperfocus on the gut microbiome. Let me explain what that is. So in alternative functional medicine circles, nutrition, whatever, as you move away from conventional medicine, you see that there's this strong focus on addressing gut microbes. And so there are practitioners who will say, okay, the only way to fix your gut is by addressing the microbial imbalances. So that can be dealing with infections, it can be dealing with yeast, it can be dealing with whatever kind of bacterial imbalance or dysbiosis is present. And this is based on the assumption, and I think there is some evidence to support this, that a microbial imbalance is associated with chronic digestive issues. I don't think it's fair to say that microbial imbalances are causative. In some cases, they might be, but I feel as though an association, people have extrapolated an association and they are implying, or they believe, that microbial imbalances are causative of gut problems. And I feel as though this is a little bit short-sighted and doesn't necessarily match up with what I have found clinically. And the reason is because there is evidence, and it does appear to play out in real life, that the microbiome can be affected by what is happening systemically, okay? So there do seem to be adaptations of the microbiome. There do seem to be things, okay, I'll give you an example. The metabolism of colonocytes, the cells lining the intestine, have a direct effect on what microbes can and cannot grow. Bacterial infections may be a symptom of a much wider problem. And the reason I say this is because I think that it doesn't necessarily get as much attention as it deserves. And whilst I do think that sometimes microbial imbalances can be the cause, and sometimes addressing gut infections can fix the problem, all too often I was seeing in many years of practice, people coming to me, patients, and you probably recognize this, we all see it, patients who have been to functional medicine doctor after doctor after doctor, and they will do a stool sample, they will do an organic acids test, and they will be diagnosed with some kind of gut microbial imbalance. The doctor will read one of these tests and they'll say, okay, the reason you have this problem is because you have dysbiosis. we need to fix this. So they will put them on either strong antimicrobials, sometimes antibiotics. They will have them doing all kinds of protocols to address the microbiome, and many cases do not improve. In fact, sometimes they actually get worse. And so this is based on, like what you were saying, this concept that if you nuke the gut bacteria, then the gut is going to start working again. So I would get a lot of people coming to me who had gone through this, and I was kind of faced with the problem. Well, I'm not going to recommend the protocols that I have learned in these functional medicine programs, because they're essentially cookie cutter approaches. And it's the same thing that this person has tried and tried and tried it and tried over again. The only way that they can manage their symptoms is by, staying on really high dose herbals. And as soon as they come off the herbals or the antibiotics, the problem recurs again. So that had me thinking, well, this can't be the cause. The dysbiosis, yes, it's present. We have test results. We have symptoms. We can say there is a bacterial imbalance, but it does not seem to be the cause, because these people are not getting consistent or long-term relief from these interventions. Long story short, sorry if that was a little bit long-winded, but that's important context here. Like you mentioned, taking a wider perspective, looking at the factors that control the gut. Well, we know that the gut, every single function of the gut, although you do have the enteric nervous system, which is essentially like a dense bundle of neurons, which is located all throughout the GI tract, that can operate semi-autonomously, meaning it can function apart from the brain. It doesn't depend on inputs from the brain. However, for optimal function and for proper digestion, it does require control, top-down control from the brain through the autonomic nervous system, primarily the vagus nerve, but also the splenic nerve. And you are getting these messages going from the brain down to the gut. And that is essentially telling the gut what to do and at what times. And not only does this control secretion, not only does this control the permeability of the gut, the mucus secretion, the motility, every single function of optimal digestion depends on the correct inputs coming in from the brain, okay? But it also has an effect on the control of inflammation. So you have what's called the vagal anti-inflammatory pathway. And this is essentially is composed of cholinergic neurons, which basically neurons of the vagus nerve, which use a neurotransmitter called acetylcholine. And these cholinergic neurons are involved in the modulation of systemic inflammatory responses. So if you've got this toxic stuff coming in from the gut, you should ordinarily be able to dampen the inflammation caused by that through action of the vagus nerve. That's one of the reasons why we're not going into perpetual sepsis every time we eat something bad or every time we have a gut infection, is because our vagus nerve is able to effectively modulate the immune system, both at the level of the gut, but also systemically, okay? So when this system, this information system goes wrong, well, what do you see? I'll give you an example. If the vagus nerve is not conducting that or transmitting that information from the brain to the gut, then you end up with hypochlorhydria, or you end up with hyperacidity. So the cells of the stomach do not get the right information, and they don't know when to produce stomach acid. They don't know how much stomach acid to make. And we know that stomach acid or stomach acidity is a risk factor for developing other chronic gut issues downstream from the stomach, in the intestine, in the colon. We also see you end up with what is roughly referred to as gastroparesis. So your stomach can't propel the food that it needs to in the right rate. Your stomach can't empty. And so you end up with this excess pressure, and that can lead to GERD. You lose control of the sphincters. So if you don't have control of the sphincters, then you're going to end up with reflux coming up when it's actually meant to be going in the opposite way. Likewise, at the level of the intestine, well, we don't have intestinal motility. This can lead to SIBO, which can either lead to diarrhea or constipation. At the level of the intestinal barrier, well, you're not making enough mucus. You can't properly seal up the intestinal the tight junctions, and so you end up with what's called leaky gut. So we see all of these different like functional gastrointestinal disorders, which are not very well acknowledged by conventional medicine, but which are heavily focused on in functional medicine. All of those, to some extent, can include in their etiology, so in their cause, a component of the nervous system. And so, long story short, I began trialing out different therapies which could work on the nervous system, or which would target the information system between the brain and the gut, rather than focusing on the gut to the brain, you focus on the top-down approach. And I would find that you asked for a number of people, approximately 30% of everyone would respond to thiamine, or 30% of the people with gut issues, and potentially more. Now, in recent years, I can't really comment on the exact percentage. I can't really estimate because my sample size is relatively biased. You know, the people that come to me or the people part of my group, I have a group over 10,000 members on Facebook. A lot of those have found my information on thiamine. And so I'm dealing with a biased population. I can't necessarily comment on that. However, what I can say is that very early on, I was finding that thiamine and thiamine derivatives were the most effective tool for chronic gut issues. And these are usually the people who do not respond or have mildly responded to previous approaches. So that would be diets, that would be antimicrobials, that would be gut repair stuff. All of these things, they tried that. They come to me, we put them on thiamine, and many times the underlying mechanisms which caused those problems would be addressed. That's how I think it's working. So you asked, how do I think thiamine is working? For those in the audience who don't know much about thiamine, thiamine is B vitamin. It's really important. In fact, it's essential to every single cell, which requires energy through mitochondria. So it is what's considered, it's a cofactor for enzymes involved in energy metabolism. And these are, in fact, rate limiting enzymes. That means that if you don't have enough B1, then the entire process of energy metabolism using oxygen slows down. It is somewhat synonymous with oxygen usage in the cell. You can think that wherever you are using oxygen, you require thiamine. Whenever you don't have thiamine, you cannot use oxygen. That's as simple as we can get. Now, it's also necessary for the production and utilization and action of the neurotransmitter acetylcholine. So refer back to when we were talking about the vagus nerve, like you mentioned. The vagus nerve is primarily using cholinergic pathways to control digestive function and to control systemic inflammation. And this is occurring at the gut. Thiamine is important for the action of this neurotransmitter, not only as involved in the raw material production of the neurotransmitter itself, but also the release at neurons and the action at adjacent neurons at the synapse. So we see that there is this very intimate connection between acetylcholine, between thiamine, and between the gut, because not only does the vagus nerve use acetylcholine, but also the enteric neurons. So you have the information is passed from the areas of the brain down through the vagus nerve, but then the vagus nerve is actually innervating this dense bundle of enteric neurons, and they're using acetylcholine as well. So long story short, to answer your question, how I think thiamine is working, well, it's probably working at 3 different levels. It is probably working at the level of the enteric neuron and the level of the intestinal cells. There is evidence showing that intestinal turnover, intestinal cells, given that they're epithelial cells, they are constantly being turned over. This requires energy hungry processes, and it requires the cells to be continually building blocks so that they can replenish and regenerate. There is a thiamine-dependent enzyme called transketolase. It shows that when intestinal cells regenerate, they require very high levels of thiamine. They also require high levels of metabolic energy, which automatically implicates thiamine. Also, at the level of the enteric neurons and the vagal neurons, as we've said, there is this acetylcholine connection. When you deprive animals or when you deprive humans of thiamine, you see problems with acetylcholine production. You actually end up with a cholinergic deficit. That's one of the reasons why it is being investigated in Alzheimer's disease, but that's another topic. And also at the level of the brain. So at the level of the brain, the regions of the brain, including the periaqueductal brain, including the medulla oblongata, the thalamus, the hypothalamus, all of these lower regions of the brain are involved in the control of the autonomic nervous system, of which the vagus nerve is part of. And the interesting thing is that if you lose or if you have damage to those regions of the brain, if you have oxygen deficits to those regions of the brain, you can end up with problems with controlling the autonomic nervous system. Now, part of that is the vagus nerve, and part of that is these people who have brain damage in these areas of the brain, they develop chronic digestive issues. So we have that connection. Now, it just so happens that if you look at the brain of someone with severe thiamine deficiency, the exact same regions of the brain are affected. Now, the research literature has not other than Dr. Derek Lonsdale and Chandler Mars, no one's really made the connection between this concept of dysautonomia, which we know is really prevalent now, especially post-COVID, but these conditions of dysautonomia, which can affect the gut, and thiamine deficiency. But if you look at the pathophysiology of both of them, there's so much overlap that you could quite accurately say that a deficiency in thiamine causes damage to the brain or causes deficits in energy in regions of the brain, which are responsible for controlling autonomic nervous system, and digestion is part of those processes. So we put two and two together and we see, well, thiamine deficiency or lack of thiamine utilization can therefore cause problems with top-down communication to the gut from the brain, and therefore can predispose towards chronic digestive issues. And that's the kind of conclusion that I came to.
That was a master class in gut health and small intestinal overgrowths.
Those processes.
And I think it makes sense for people to really explore these broader, more holistic areas of gut health. Unfortunately, I see people that are on Xifaxan, rifaximin, antibiotics for years or indefinitely, because every time they stop, to your earlier comment, these issues come back again. And if we could get some of these foundational pieces in place, I would suggest that many times that would not be the case. Next, I want to talk a little bit about another topic that's not widely discussed. And I learned about this originally from Dr. Greg Nye and Stephanie Seneff. I was impressed to recently find that you've also done a teaching video on this topic, and that is sulfate deficiency. So wondering if it could be the case that SIBO is an adaptation of the body to address sulfate deficiency. And if that's potentially true, could Epsom salt baths, which are magnesium sulfate, could that be a helpful tool in also moving beyond SIBO? And then just adding to that, do you do any testing in your clients to get a sense for the potential level of sulfate deficiency?
Yeah, so that's a topic that I've not looked into for about 5 or 6 years now. It is something that caught my interest back before I started using thiamine. It was around kind of a similar time. I published some articles and I had come across Greg Nye. I actually had some discussions with Stephanie Seneff. And before I knew that Greg had made the connection with SIBO, I'd actually been speaking to Stephanie Seneff and saying, well, actually, do you think that this might have something to do with why people have gut issues? And she's the one who put me onto Greg Nye. She says, look, he's already gone there. So it was fascinating when he made that connection. It does seem as though some people who do have a subtype of SIBO, which is now referred to as hydrogen sulfide dominant SIBO. It wasn't that common or well known back then. I think there's much wider recognition of it now, and it's seen as a distinct clinical entity. For the listeners who aren't aware, it's based on the concept that instead of having a primarily hydrogen or methane dominant overgrowth, it's dominant in bacterial species like Desulfovibrio and Bilophila wordsworthia, which are known to generate high amounts of hydrogen sulfide, and that can be problematic for various reasons. And these people usually have very poor tolerance of sulfur-containing vegetables and sometimes even meat, or any supplement which is naturally high in sulfur or contains an added sulfur group. So these people generally would get signs and symptoms when they eat those foods rather than just general FODMAPs. So with that in place, I had tried some of the recommendations of Dr. Nye in several clients. I'd not found that much benefit. People putting them on like a low sulfur diet and then using some of those supplements. I didn't personally find that they worked. However, I happened to stumble across a different treatment for that. And honestly, my thinking on that has progressed to the point now where everyone who comes to me or who I would consult with hydrogen sulfide dominant SIBO, I would put them on a low oxalate diet. And 9 times out of 10, that would fix the problem. So I suspect that, and this was really born out of the work of Susan Owens, who was originally actually a sulfur researcher, chemist or biochemist, or can't remember exactly what profession she was in, but she was researching sulfur in its relation to autism. She then stumbled across the connection of autism and oxalate, and she went on a deep rabbit hole and has become one of the leading experts in the field of oxalate and how that negatively affects humans. But there is a very close kind of crossover and many interrelated pathways of sulfur and oxalate. And it would appear that when someone's physiology, when someone accumulates excess oxalate in their soft tissue, in their cells, then that has a very detrimental effect on their ability to handle and metabolize sulfur. And so I stopped using the recommended protocols for people with hydrogen sulfide dominant SIBO, and I just put them on low oxalate diet. And I found that, again, 9 times out of 10, that would fix the problem. And looking at some of the connections between sulfur and oxalate, we can hypothesize why that might be, although I'm not exactly sure that the science has been well characterized. So in terms of testing, I would do it mostly on symptoms. And that's really the case for most things these days, unless it's like really, even if it's looking for some kind of a chronic infection, I would refer on. So I don't deal with people with stealth infections, with Lyme or anything like that. It's really not my field. I would refer on to someone else. And so for most other things, I may do an organic acids test, but for the most part, I've been let down so much by functional testing, particularly in relation to things like gut bacterial testing and things like that. Unless it's a clear sign of an actual pathogenic infection of the gut, then for the most part, I don't test. I don't test other than standard blood work.
So let's then talk a little bit about oxalates. What's the connection between oxalates and thiamine? How often do you see excess oxalates being the result of thiamine deficiency? I know you said the people that you put on the low oxalate diet, 9 out of 10 of them seem to help, but is that potentially the result of B1 deficiency? And then when we reintroduce or introduce B1, do we have to potentially be careful about that also leading to some dumping of oxalates, maybe increasing people's pain, maybe the potential for kidney stones, that we do sometimes see those types of oxalate dumping issues with more aggressive dietary restrictions? And do you think that oxalates are primarily coming from our diet or from the internal fungal colonization that may be creating endogenous oxalates?
A lot of what I'm going to say right now is purely anecdotal. And this is something that as a practitioner, you will see, and many other practitioners will see. We don't understand why these things happen, right? There's theories for why, and there's maybe some theoretical justification, but ultimately it is still somewhat of a mystery. And I think because they are heavily understudied. So we've touched on 3 subjects here. We've touched on thiamine for the gut. We've touched on hydrogen sulfide dominant SIBO or sulfate deficiency and oxalates. And there's very interesting, this is all the stuff that I was kind of trying to tie together 5-6 years ago, and ended up just focusing on thiamine, but it could have been the other way around. There is an overlap and they tend to coexist. And this is where things get quite confusing. Let me just expand on that a little bit. So if you have someone who has a hydrogen sulfide dominant based gut condition, the hydrogen sulfide itself in animal research has been shown to destroy thiamine. And we don't know whether that is because of the hydrogen sulfide, the gas destroys the thiamine molecule, or whether because it's converted into sulfite by cells. Sulfite is a toxic derivative of sulfur. And we know that the sulfite does destroy thiamine. And so in animals, for instance, if you look at animals that accidentally feed on high sulfur diets for prolonged periods of time, they end up with a type of what's called encephalopathy, like a brain-based inflammation. And many times they can die because of that. And they suspect the mechanism is because it induces thiamine deficiency in the brain. Now, we can extrapolate that and say, well, if someone's producing a lot of hydrogen sulfide in their gut, we know that hydrogen sulfide can essentially just dissolve through tissues. So it just dissolves through the membrane of the gut into the blood. It just dissolves through tissues. It's very interesting type of gas like that. It doesn't require a transport system. It just dissolves. So can we speculate whether hydrogen sulfide can, through this action, and because it is so pervasive, does that destroy the thiamine that's generated in the gut by the microbiome? Does it destroy the thiamine that is coming from the diet? Does it destroy the thiamine in the cells, in the blood? I don't know. I think it's possible because there is a significant overlap between people who have H2S dominant SIBO and respond to thiamine. You know, we were saying that maybe 30%, maybe even higher, respond to thiamine and thiamine derivatives in terms of their gut issues. Maybe it has to do with that. I don't know. That's just another interesting connection. But then we look at oxalates. And like I said, multiple overlapping factors here. There are some old research studies which were looking at the effects of a deficiency of thiamine on endogenous oxalate synthesis. And they showed that if you make rats thiamine deficient, they will generate high amounts of oxalate. And I can't remember the exact mechanism. It's an enzyme. It's not AGXT. It's one of the other enzymes that is essentially blocked off in thiamine deficiency that causes the precursor of oxalate, glyoxylate, it's called, or methyl glyoxal into glyoxylate, and then that leads to the endogenous synthesis of oxalate. And you can actually have quite a lot of this in a severe deficiency. So there is that connection as well. Now, a lot of this I would defer to Susan Owen. She's the expert when it comes to oxalate, but looking at the connections between oxalate and sulfur, it would seem as though, at least at the level of the kidney and maybe elsewhere, maybe at the level of the gut, I think there are these transporters called SAT1 transporters and SAT2 transporters. The way that they work is for every one oxalate ion that is moving in one direction, you have sulfate, which is being kicked out on the other direction. And so it's theoretically possible that if you are having a high oxalate diet, which I'm going to assume that your listeners are familiar with, because since you've talked about in the past, if you have someone who has a high oxalate diet, or they have a high endogenous production of oxalate for whatever reason, there could be various reasons for that, then it is theoretically possible that that is going to cause a wasting of sulfur at least at the level of the kidney, but also potentially at the level of the gut as well. And so for the oxalate that they are absorbing, they are kicking out or they are wasting sulfate. And that is really kind of important to understand, because sulfate is one of the things that help protect you against oxalate, in that it helps to repair the damage that is caused to the connective tissue and to all of the other types of tissue that oxalate naturally causes. For instance, oxalate will cause damage to the tendons and the various soft tissues, and sulfate is going to be used incorporated into rebuilding those tissues. And so you really want enough sulfate if you've got problems with oxalate. Now, I do believe as though it works the opposite way around as well. And what I mean by this is by giving the body high amounts of sulfate, it's also theoretically possible that you could help the body get rid of excess oxalate. I think that's the working theory. And this does also appear to play out in real life. Like you were saying, causing symptoms. Again, I'm going to assume that your listeners are familiar with the concept of dumping. For those who aren't, very quickly, the idea is that when your blood level of oxalate does drop, because you restrict it in the diet, then your body perceives that as a signal to mobilize and excrete what it has stored. This is a real phenomenon. This happens. There is a very old study which showed this in primary hyperoxaluria, but it was never followed up. So before people ask about the science, there's very little, but I'm telling you, the testimony of tens of thousands of people, this is 100% true. It happens. So when someone's dumping, there are certain things that you can take. There are nutrients, there are practices that you can do which can enhance this process or which can speed this process up. One of those is giving the body inorganic sulfate in the forms of Epsom salt baths, which is ironically, this is also one of the treatments that's recommended to deal with hydrogen sulfide dominant SIBO. So again, a lot of the stuff that Greg Nye and Stephanie Seneff tapped into, and they were recommending to treat hydrogen sulfide SIBO, I don't think they made the connection, but a lot of those things were actually the same things that you would be doing to address oxalate problems. And so it does seem as though there is a connection between the two. I don't know the exact mechanism by which oxalate problems would cause hydrogen sulfide dominant SIBO, but there's a massive overlap. And just to give some anecdotes, I mean, I had one lady, well, I've had several clients who have gone through this, when they would so they would come to me for hydrogen sulfide dominant SIBO. We'd put them on a low oxalate diet, and they would usually notice an immediate improvement in symptoms. But then they would go through those classical signs of oxalate dumping. So sometimes it could be the oxalate crystals coming out the eyes, coming out the skin. They'd have systemic joint pain, all this other kind of stuff. But at the same time, they would notice flare-ups in their hydrogen sulfide dominant SIBO symptoms as well. And that became one of the metrics by which they knew that they were dumping. That's a bit of interesting information, but it seems to play out. And they would go
so that was just your thoughts on whether or not introducing thiamine alone without significant dietary changes could also lead to a oxalate dumping that could be problematic or not.
Anecdotally, it does. Anecdotally, it can. Yeah. And I don't know the exact mechanism. I believe that Susan Owens has speculated that if a deficiency is one of the things that causes endogenous oxalate production, theoretically, when you were to address that deficiency, then the production of oxalate is going to decrease inside the cell. What that is theoretically going to do is reduce the amount that's in the blood, and it's going to cause the equivalent situation as to if you were to reduce it in the diet, because the amount that's coming, the consistent amount in the blood is going to drop. So whether it's coming from stopping endogenous production or whether it's coming from reducing the amount that you're eating in the diet, the end result is the same, and therefore it will trigger the body to start this mechanism of clearing out oxalate. And so sometimes you do see that with people who start thiamine. They may see very good benefits to start off with, but then they start to notice all these strange symptoms. Unfortunately, it's just so hard to pinpoint. You know, there are so many potential things that could be causing that it's hard to say, well, that's because of oxalate dumping. No one has really devised a test for this. No one, I mean, they try to, but the urinary oxalate levels are kind of notoriously problematic for determining if someone has an oxalate problem. So a lot of it's just anecdotal at this point. That's the best we've got.
As a nutritional therapist, wondering what your thoughts are on the carnivore diet. Is a plant-based diet generally health supporting, or is it health negating if we're avoiding plants entirely or mostly long-term in an attempt to avoid their defense chemicals such as maybe oxalates or lectins? Can that potentially lead to more problems than it solves? And can a diet like the carnivore diet with more limited diversity lead to a less diverse microbiome over time?
Yeah, great questions. I can't answer most of those. I can just tell you my experience. With regards to the carnivore diet, I see it as an excellent tool. There do seem to be people who can live like that. They live optimally, it would seem, long-term on that kind of diet. It would seem as though some people, whether because of immunological problems or whatever, they seem to be dependent on that kind of diet. And I don't know exactly why that is. But likewise, there do also seem to be people who follow plant-based diets and seem relatively healthy from that. So I can't say that I disagree with any of those diets. I generally do not advise anyone go on a plant-based diet. But if you do have outliers and there are people who seem to function healthily, I'm not going to tell them to stop doing that. I think that the most important thing for me is trying to optimize nutrient density, which without doubt is increasing animal foods. Animal foods are the most nutrient dense, and they hit the widest spectrum of nutrients. And there's many nutrients in animal foods that you simply can't get in plants. And it's not really the case the other way around, apart from the electrolytes and some of the trace minerals and things. You can get most of what you need through animal foods. I do believe that. It's not necessarily saying that I recommend these diets long-term. However, if someone has gut issues, which was part of the discussion prior, I do feel that the carnivore diet is a very good reset. It's a very good tool. And it's something that can be used just to calm things down, because you have to factor in, if someone has very severe dysbiosis, they have intestinal permeability, they have gut infections, they have all of these problems. It's like if you're feeding them FODMAPs and you're feeding potentially harmful plant defense chemicals, what a healthy gut may be able to cope with, these people seem to be way more susceptible to those negative effects. And so what I like to do is remove as many of those potential inflammagens as possible, just temporarily, until someone gets to a point where they have greater resilience, and then they can look at reintroducing things. And I don't have a problem with things like fruit, even starches to a large extent. Like, honestly, I had done carnivore for quite a long time. I feel better eating a good amount of starch every day. It helps me retain weight on carnivore, particularly if you're a young guy with high metabolism. I work with guys in their 20s, and they generally don't do very well on carnivore because they lose too much weight. They find it difficult to maintain muscle mass. Now, there's always outliers to that, but I do find as though there is this correlation with age and requirement for carbohydrates. And I find that maybe as someone gets older, their requirement probably goes down. I don't know the mechanism that would explain that, but it does appear to be the case. So I'm not opposed to any particular diet other than raw veganism, but I do think that animal foods in sufficient quantities, let's say, a wide spectrum of animal foods, is probably the best way to hit all of those nutrient bases. All I can say is that if we're going primarily by symptoms, there seem to be people who have very healthy digestive systems on long-term carnivore. I can't deny that. And there are some people who have done stool testing, and they've actually found increased diversity after being on carnivore diets. Once again, I can't explain that, although I think that human beings appear to be quite resilient and adaptable. And I think that it would make sense that we had mechanisms by which we could bypass a lack of food availability. For instance, there's nutritional ketosis. I suspect that in times of famine or whatever, there are ways in which we can replenish gut microbes through alternate pathways other than feeding dietary fiber. I mean, I'll give you an example. There was a paper I was reading prior. It was talking, we all hear about the benefits of fiber being one of the primary benefits appears to be in relation to promoting butyrate producing bacteria, enhancing butyrate production. Now, there are a lot of studies which show no correlation between fiber intake and butyrate production by the microbes. Just want to put that out there. But let's say, even based on the assumption that fiber does categorically increase butyrate production, we know that butyrate is important for the health of the intestinal cells. There was a study I was reading, and it was speculating. I can't remember whether they had actually shown that it could occur or not, but there's some speculation regarding whether you may be able to use beta-hydroxybutyrate, which is a ketone body, as an alternate source of butyrate. And this may be able to explain why people in long-term ketosis don't see massive detriments in their digestive function. It could be that actually we have an alternate supply of butyrate for colonocytes. It's not coming from dietary fiber, but it's actually coming from either dietary butyrate in its whole state, or it's coming from the metabolism or breakdown of endogenously produced ketone bodies, which can potentially facilitate energy production that way. So I honestly don't know if I think anyone who claims to know the answer to that question is probably just suffering from Dunning-Kruger, because at this point, it seems as though the evidence is not there to say that you need fiber for a healthy gut. Now, I eat fiber, and I'm not opposed to fiber, but it does seem as though there's outliers, and I'm open to learning about that,
So building on the carnivore topic, and this is not specific to carnivore, but if we're eating a lot more red meat, potentially we're getting a higher level of iron. You and I both dealt with high iron, potentially related to mutations in HFE and other related genes. As I understood, you approached your iron issues with therapeutic phlebotomy, which I also thought about. But interestingly, I decided to use IP6 and luteolin and other nutrients to lower iron, primarily because the practitioner that I was working with, he's an incredibly bright guy, when we already had a focus on nutrient deficiencies, the concern was that removing a significant amount of blood potentially creates more demand for nutrients to then create new blood and potentially fixes one problem but creates another. Wondering if therapeutic phlebotomy is something that you think you will do long term, or if you're finding other ways to manage that high iron issue.
Yeah, honestly, it just seems for me the lowest hanging fruit, simply because it would require a lot more effort, a lot more time, planning, and cost to try and micromanage my iron intake. I've kind of got to the point where I've just accepted that I have a hereditary genetic tendency, and it may have served a useful purpose for whatever reason historically, but in our modern day, it's not serving that purpose. And rather than absolving from eating red meat, which I'm not going to do, weighing out the pros and the cons, the easiest thing for me personally is simply to take my own blood every 6 to 8 weeks. And I monitor that. And I can feel immediately after I take my blood that my energy levels improve, my muscle recovery improves if I work out, and my sleep improves and things like that. So I generally don't tend to advise people on this as well, because it is a medical topic. Actually withdrawing one's own blood, it falls within the realm of medicine. I try not to go there for legal reasons, but I say for myself, I find it's the simple and most effective way to do it. Now, without doubt, it's going to increase the need to produce new blood cells, and therefore you're going to be placing a slight demand on some of the other nutrients. For me, that's not so much of a concern. The amount that is stored in the body is relatively minuscule compared to what you can take in a B complex, so I'm not too concerned about that element of it. That's not to say that phlebotomy is beneficial for everyone. In fact, there are many people who find that they feel particularly drained and fatigued after doing phlebotomy. They can make themselves anemic. It's something to do under the supervision of a qualified practitioner. I can only speak for myself in that I feel like I benefit from that.
So let's talk now about COVID and long COVID. Wondering what you think the long-term impact of spikeopathies might be. How do we best detoxify or remove spike proteins from our bodies to maximize our health? How do we best support the endothelium and address inflammation of the endothelium or endotheliitis? Potentially hypercoagulation or clotting, huge issue in the pandemic era as well. Wondering what you see as the key contributors to the millions of people now dealing with long COVID, and is there a place for thiamine in supporting the body in the realm of COVID?
Yeah, so there's probably 1,000 things that you could cite as being potentially beneficial for people with this condition, but the main areas that I have focused on and that I found to be the most helpful are going to be the things which, in theory, can directly degrade or change the structure of spike protein. You're not necessarily going to stop people from manufacturing in their cells, because it would seem as though the research suggests that this can go on for a very long time after having these boosters or these shots. And so I don't know if you're necessarily going to be able to, you have to deal with the downstream effects of what they have put in the body. And so what appears to be useful are any kind of systemic enzyme, so any kind of proteolytic enzyme. And this can range from serrapeptase to nattokinase to lumbrokinase. Any of those three, or a combination of all those three, appear to be helpful, along with bromelain. Now, there are some studies which were showing that those enzymes, or particularly bromelain, nattokinase, could have direct effects on the spike protein to degrade it. And that also correlates with anecdote. There are a lot of people using these combinations, and they're finding significant symptomatic relief. Now, this is not only people who have had the shot, but it's also people who got long COVID, because it has been shown that people have residual viral spike protein in the tissue that their body can't actually get rid of. Even that's not even having, I'm sure you've spoken to people about this. This is not even people who took the shot. They got long COVID before the shots even came out. And it's like this residual viral spike and leftover viral particulate is stuck in the tissue, and the lymphatics are blocked, and basically they can't mobilize it. They can't get rid of it. whatever you think of as the origin of that particular thing, which, we have to be limited on what we can talk about, it would seem as though whatever designed that really made something which was novel for sure, because it operates in a different way to most other viral infections. But based on what we know about the spike protein, the proteolytic enzymes, without a doubt, anything which can disrupt the sulfur bonds of the spike as well. So NAC and glutathione, both of which were found to have direct effect on spike protein. So you've got your proteolytic enzymes, you've got your NAC, glutathione, but then really anything which can support the endothelial layer of the vascular system. So it's a vascular system which really gets hit perhaps the hardest. So anything which can improve vascular function, herbs being ginkgo, anything which can improve endothelial nitric oxide synthase. So that can be citrulline, it can be arginine. Really, there's no limit. Any nutrient that you can think of, aged garlic extract even, there's reports of people finding benefit from that. Any vitamin C, anything which reduces oxidative stress at the level of the vascular endothelium, that's important. Now, in terms of dealing with the, let's say, more widespread consequences of long COVID or the V injury on systemic physiology, well, you find that oftentimes there is this strong component of dysautonomia, autonomic nervous system, which we spoke about briefly at the start of this talk. And you see this massive surge of people reporting POTS, postural orthostatic tachycardia syndrome, and other forms of autonomic nervous system dysfunction. And these are going to typically present as anything where any of the functions controlled by the autonomic nervous system. So heart rate, blood pressure, vascular dilation, body temperature regulation, digestion, sweating, anything which your autonomic nervous system is in control of, this can go completely skewy. And so you have all of these people with just widespread symptoms and they have no kind of explanation for that. And this is where, not exactly sure why this occurs, but it does seem to be that things which promote the cholinergic neurotransmission, probably through working through the vagus nerve or potentiating the action of the vagus nerve, appear to be greatly beneficial. Now, something that I can't or that I haven't been able to discuss much publicly is nicotine. And I can say this just for you. Nicotine is one of the most effective things that I found for long COVID. And probably because, nicotine has been shown to directly inactivate spike protein. It seems to block spike protein acting on ACE2 receptors. This was known very early on in the pandemic. So it was shown that smokers in China were not getting COVID. And then it was also replicated elsewhere. So they were finding this bizarre connection. Smokers typically are going to be the most likely to develop lung conditions, but they were finding that they weren't getting COVID. And if they weren't really getting all that sick from it. Now, that's not to say that smokers, in the West have not been known to get it, but as a general trend, they seem to have greater protection. So this spurred some research into looking at the mechanism behind that. And now it's possible that we know that nicotine does seem to have these direct effects on the ACE2 receptor, but also on the spike protein itself. However, nicotine is also one of the therapies that has been used by some forward-thinking doctors to treat dysautonomia way before COVID came along. And this is because the receptors in the autonomic nervous system for choline, you have these two different subtypes. One is called muscarinic cholinergic receptors. Another one is called nicotinic acetylcholine receptors. And so what nicotine does is it binds to those receptors and acts in a way that acetylcholine would. So it's almost tricking your body to think you have more acetylcholine than you actually have. So it basically activates all of those cholinergic functions. And if you look at some of the older research on nicotine, you'll see that there's even a paper published in 2006 called Nicotine, the Anti-Inflammatory Molecule. And it goes through all of the different conditions which have shown that nicotine has this very strong anti-inflammatory effect. And now they know, or now they believe, it's probably due to the fact that it's potentiating this cholinergic anti-inflammatory pathway through the vagus nerve, not only to reduce inflammation in the gut, but also to reduce systemic inflammation. And so really anything, if you look at some of the research, flitting back and forth. I'm just trying to think of things that are just coming to me. There's some interesting lines of research looking at spike protein and its effect on cholinergic neurons. So they're finding massive cholinergic deficits in people with long COVID and people with spikeopathy or whatever you want to call it. And so it would seem as though nicotine is working probably via potentiating these cholinergic pathways, restoring not only cognitive function, but also restoring action of the vagus nerve. Now, it just so happens that thiamine does almost the same thing. Now, I don't think there's any research looking at thiamine's direct effect on spike protein, but what we do know is that thiamine also is necessary for cholinergic function, potentiating the action of acetylcholine, kickstarting the brain regions of the brain, kickstarting cholinergic function in the brain, restoring cognition, restoring vagus nerve function, restoring this cholinergic anti-inflammatory pathway. So you have these two very different substances which actually seem to have a very similar effect. And so in answer to your question, have I found thiamine useful in people with these problems? The answer is absolutely yes. Aside from all of those very, I don't want to say conventional spike protein treatments, but I want to say better known spike protein treatments. Something I would say, particularly for the nervous system, is this combination of using nicotine and thiamine coupled with magnesium. Sometimes people don't want to take the nicotine, so you can just use the thiamine. So if you use that in combination with those other more spike protein oriented therapies, you can see major results, sometimes within days. And there are people, as you know, people with long COVID, they report chronic digestive issues, they report dizziness, severe fatigue, things like that. More often than I would have ever thought, they are responsive to thiamine. And I think it's primarily working through a very similar mechanism that we were talking about at the start of this discussion, in the way that it's actually fixing gut problems.
My observation has been very similar to yours with nicotine in those people with long COVID. I think Dr. Brian Ardis, Dr. Dietrich Klinghardt, others in my circle that have talked about that. And it definitely seems to be one of the most beneficial tools for people dealing with long COVID. We know the microbiome, and particularly bifidobacteria, plays a role in the severity of someone's COVID. That work came from Dr. Sabine Hazen. Wondering if you think it's important to support bifidobacteria or support the microbiome as well in the context of long COVID.
Yeah, her research is fascinating. I think it's probably important. The question is how to do that in an effective way, because simply taking bifidobacteria supplements doesn't necessarily shift those levels. And this is where I wonder, I mean, I can't say with any certainty whether any of the therapies that I know of other than FMT, and I don't even think FMT works all the time, whether anything can genuinely shift those numbers in someone who has this kind of injury. And there are probiotic yogurt, for instance, and they seem to work in a positive way, and people do seem to report benefits in their symptoms. I've not done testing before and after. Dr. Sabine probably has a lot more information on that. I read a few of her papers last year. I've not checked her out recently. I think it's probably important. It's just the question is how to shift it in any meaningful way, in the most effective way. It comes back to that concept that the microbiome, honestly, it seems to be interrelated with what's going on with wider systemic physiology. And that if someone does have a particular illness, can we accurately say that the microbiome is not disrupted as a consequence of that? Perhaps those dysbiotic changes, and this might seem a little bit weird, but I do think that there is an innate intelligence, whether it's the divine, whether it's God, whether it's the universe, whatever it is, there's this innate intelligence of the human body. And I wonder whether some of these dysbiotic changes are in fact adaptations, and that the changes that you see associated with diseases, perhaps that is actually having some kind of a beneficial effect. Perhaps the microbiome is changing in order to help detoxify certain things. How do we know whether spike protein is not? And take this for what it's worth. This is purely speculation. I have no evidence for this. But, if spike protein is being transported into the gut, are dysbiotic bacteria actually capable of destroying that? Are they metabolizing that? Are they clearing that out of the body? I don't know. I just wouldn't be surprised, and it would make intuitive sense to me that there were some kind of backdoor mechanisms involved there, and whether kind of playing God, I feel like that's what people try to do very frequently, is play God. We look at we look at test results and we say, oh, this is a problem, we need to fix this. And sometimes maybe that's not a problem, maybe it's a symptom of a wider problem, and that might be why it's so resistant to change sometimes.
Yeah, I mean, I think it's interesting too that now there's some research suggesting that SARS-CoV-2 actually infects our beneficial flora in the microbiome and then potentially continues to replicate in our own microbiome, which is kind of an interesting problem to see how we eventually solve that. Let's talk a little bit now more about thiamine, a little more focus on that. So what symptoms or conditions might lead you or should lead someone to consider exploring thiamine depletion or deficiency as a contributor to their condition? And how far-reaching, I mean, it seems pretty clear already, but how far-reaching are the effects of thiamine on the body and its function?
We need to lay down some groundwork, and this is for the listeners so that they understand the perspective that I'm working with here. And this is, let's say, counter to the conventional concept of nutritional sufficiency and deficiency. And the reason I say this is anyone who's gone through any kind of medical nutritional training, we are taught to look for deficiencies and we're taught to test for deficiencies. And there is this underlying assumption, it's incorrect, but it's an underlying assumption that nutritional status exists on a binary, right? That there is sufficient and deficient. It's one of those two boxes that you place someone in. Whereas in reality, it couldn't be further from the truth. There is a continuum, which you understand and probably most of the listeners understand. But it's really important to grok that, is there is a continuum in which someone is all the time is moving back and forth, depending on your demands, depending on your physical activity level, your diet, your stress level, your toxic exposure. Every single thing that you come into contact with that you do affects your nutritional status in some way, because nutrients are the way in which the body adapts to various demands. Okay. So if you have higher stress levels, your body uses tools and those tools require nutrients. And so really there's this wide continuum and people are always moving back and forth towards positive nutritional status or towards deficiency. And rarely do people actually get towards full-blown deficiency. So if you look at the literature, most of it is focused on identifying full-blown deficiency diseases. Now, if you were to actually go through someone's history, you would figure out that they had signs and symptoms which could pinpoint an insufficient level of that nutrient probably years before they get to the point where they're admitted to hospital. What this tells us is that it can take a very long time of someone having suboptimal status or not being able to utilize the nutrient before they ever get into a diagnosable state. And this is really the biggest problem, biggest misconception by modern medicine, how they understand nutrients, nutrient handling by the human body and how it relates to disease. I would say that there is nutrient mishandling or insufficiencies involved in every known disease. And this is because, like I said, the body needs to adapt to stress. And the way that it does that is it does it via micronutrients. Of course, that's a vast oversimplification, but the fact is you are using micronutrients in every single way to protect and repair the damage caused by any form of stress, whether it's infection, whether it's a direct acute injury, whether it's a chronic exposure to a toxin. It's your nutrients that are being taxed. Okay. So sorry, I just needed to get that out of the way. Now, to understand the kind of breadth and depth of uses of thiamine, we have to work from the assumption that the body, or I don't want to say the assumption, but the kind of working foundation that the body is using nutrients to counteract stresses. Now, it just so happens that if you look at the evidence, not only in humans, but in organisms, all types of organisms, ranging from fungi, plants, bacteria, what you see is that one of the first responses to a vast array of different stresses, and this can be abiotic stresses, biotic stresses in plants, it can be drought, so dehydration. In bacteria, it can be various things. It can be radiation. In human cells, the kind of prototype of a stress is hypoxia, right? Hypoxia, lack of oxygen. Now, one of the first things that all of these cells will do in response to any kind of stress is rapidly increase the uptake of thiamine. into the cell. In plants, in bacteria, what they do is they can synthesize their own thiamine. Humans can't. One of the first things they will do in response to stress is increase the synthesis of thiamine-dependent enzymes, of thiamine itself. So what you see as this kind of unified or universal response to stress of multiple kinds is the increased utilization and uptake of thiamine. And what this is ultimately what I feel like it hints at, and the perspective that I've been led to after all these years, is that thiamine is one of the most important tools that the body will use to adapt to environmental challenges. And what I mean by that, I'm not being specific because it is non-specific. It can be depletion of resources, so it can be excessive exercise, it can be infection, it can be toxicity, it can be chronic inflammation. Any of these things, the body will use or tap into its thiamine stores and utilize at a greater rate. Now, this is reflected in the literature, is that if someone has any kind of a critical illness, they will go into the hospital, let's say with a normal thiamine status is measured by, plasma thiamine, and then within like a couple of days, it will have tanked down to like 10%. And that's not necessarily just because of parenteral nutrition, although that is a risk factor, but it's because the metabolic demands of illness itself requires that you use massive amounts of thiamine. So just to get that out of the way, what that means is that anyone with any kind of a chronic illness can potentially be someone who requires and depends on higher amounts of thiamine. Now, there are some kind of very specific ways. I don't want to be completely non-specific about that because there are some telltale signs. I would say anyone who has any sign of autonomic nervous system dysfunction, okay? Now, that is really broad. Like by its nature, it's completely broad. So you have problems with temperature dysregulation. You have problems with digestion. You have problems with excessive sweating. You have problems with high heart rate or low heart rate. You have problems with muscle contraction, or you have problems with blood flow. It's super non-specific, but really, in my experience, anyone with any kind of autonomic problem can be a responder to thiamine. Why? Because of all the mechanisms that we spoke about before. Now, what the earliest researchers found, there's actually a goldmine of a study published in 1940. It was one of the first ever, and I'll actually send you this study because I think you might be interested to read it. One of the first ever controlled studies by which they tested thiamine deficiency in human beings. It was identified in Japan. They learned a lot about it, but there was very few controlled studies. This was in the West. Anyway, so published in 1940, there was actually a series of like 3 or 4 experiments by the same researchers. What did they find? Well, they found that after 88 days, so almost 3 months of having these individuals on a diet containing only 10% of the amount of thiamine, what they expected was that these people would develop full-blown thiamine deficiency, as known as what's called beriberi, which is either severe peripheral neuropathy, loss of the function of the peripheral limbs, paralysis, problems with the brain, very severe condition, can lead to death, or heart failure, which is another one of those end-stage deficiency diseases. They expected to find that very early on. They were surprised to find that not one single participant developed any of those symptoms, even after 90 days. Instead, what they developed was just a wide variety of completely non-specific symptoms, many of which you would now either diagnose as a functional gut disorder, or you would diagnose as some kind of a dysautonomia. But I'll give you a couple of those. So they found in every single participant, one of the first signs and symptoms was gastric hypochlorhydria. So the stomach stopped making stomach acid. They found constipation, so their intestinal motility slowed down. Also one of the first signs and symptoms. Again, this would now be, what this led to was belching, bloating, constipation, abdominal pain, reflux, all of the symptoms that now we treat as functional gut disorders. They were like some of the first earliest signs of thiamine deficiency. Somehow this was never translated into clinical research. It's bizarre. They also found fatigue, lethargy, mood disorders, apathy, high heart rate, dizziness upon standing. Basically, all of the symptoms of POTS, they developed. Someone developed at some point very early on. They found that as soon as they gave them the normal amount of thiamine, all of these symptoms disappeared. So they concluded at the end of the study that thiamine must not be the cause of beriberi because it didn't cause it in any of these participants. They actually said, oh, we must have got it wrong. Thiamine can't be the cause because it didn't cause it in these participants. But actually, they were wrong. But what they really showed, they illustrated the point that I was trying to get at, that nutrient status exists on a continuum, and therefore someone can be mildly or chronically insufficient without ever developing a diagnosable deficiency disease and having normal blood levels. And what they would find is that actually they display a wide variety of other symptoms. And the simple reason for this is, aside from the autonomic nervous system, you have to factor in that every single cell that requires oxygen, that requires energy, needs thiamine. And since thiamine is a rate limiting factor in energy metabolism, if you don't have enough, it really doesn't matter if you have enough of the other nutrients, because if you don't have enough B1, then you're not going to be able to turn that oxygen or utilize that oxygen to make ATP. So hypothetically, and this could really kind of explain why it's so non-specific, is because a mitochondrial or a lack of energy in any of your organs in anywhere in the body can realistically lead to any type of symptom. Now, I'm not saying that thiamine deficiency leads to every single symptom, but it can hypothetically. And this is why it's really kind of hard to identify. There's no one particular clinical picture that you're looking for. You're looking for, one person can come with debilitating fatigue. Another person can have debilitating fibromyalgia. Another person can have way too much nervous energy and serious like chronic anxiety and bipolar disorder. All three of them can respond to thiamine. All three of them have normal test results. We can understand this now based on literature, which is showing a mitochondrial etiology in many of these diseases, whether it be brain health, whether it be, neurodegeneration, whether it be fibromyalgia, whether it be chronic fatigue, whether it be digestive issues, there seems to be a mitochondrial component. So any condition which involves a mitochondrial component could theoretically be caused or could be mimicked by a mild deficit in B1. That's as simple as I can get with it.
You talked about a lot of the things that potentially lead to utilizing more thiamine, leading to deficiency. You've talked in some other work about higher refined sugar, higher processed carbohydrates, alcohol, tea, coffee, some medications, I believe metronidazole being one of them, that can also impact our thiamine levels as well. So it seems like there's a lot of ways that we potentially can become thiamine deficient. Wondering, how do you test for thiamine deficiency? Are you looking at micronutrient testing? Are you looking at organic acids? How do you like to test for thiamine deficiency, or are you more looking at clinical presentation and symptoms?
So in the early days, I would do every known test for thiamine deficiency that I could get my hands on. It would be plasma thiamine. I would, if it was available, the erythrocyte transketolase test, the LabCorp thiamine pyrophosphate whole blood or red blood cell. I would do the organic acids testing. And honestly, about 2 years into it, I stopped using any of that. And the reason was because I was seeing people who had normal test results. I would not recommend thiamine, yet all of their symptoms matched and their clinical history matched someone who would respond. But because I had asked them to spend $300 on a test, you know what it's like when you're trying to encourage a client to spend a lot of money out of pocket on a functional test, and then the test doesn't show that they are deficient in a nutrient. Well, you're not going to have much success with recommending that nutrient. Otherwise, it would implicate, or it would suggest that the test they've just spent €300 on wasn't very accurate. So I would see this happen probably countless times, maybe not countless times, but several times before I finally got the message. These people would not be, I would not recommend thiamine. They would disappear. And then on several occasions, they would come back to me and they say, hey, Elliot, just to let you know, I watched one of your videos a couple of months ago. I decided to go ahead and start high-dose thiamine, and wouldn't you know, most of my symptoms disappeared. Just letting you know, even though the test didn't show, I still responded. So that happened enough times that I kind of began to see that there was something else going on here, and tests were, in many cases, missing the people who would respond. And so how to understand that? Well, it comes back to the work of Dr. Gary Gibson and Victoria Bunick. What the researchers have essentially shown is that, and this is again something that is not very well acknowledged, not only by conventional medicine, but also alternative and functional medicine. They don't understand this concept. And this is something that I'm trying to scream from the rooftop, Scott. Like, honestly, I need people to understand this because this is so important. And it doesn't just apply to thiamine, it applies to the other nutrients as well. What they found specifically with thiamine is that you can be deficient in a single organ. In fact, no, you can be deficient in single cells of a single organ. I'll give you an example. In Parkinson's disease, the substantia nigra, okay, the area of the brain that produces dopamine that is notorious for degenerating during Parkinson's disease. What have they shown? They found localized cell-specific thiamine deficiencies. And they don't know whether that's because of a transporter defect that is specifically located on those cells. Whatever is happening, you are ending up with an intracellular deficiency, which is not global to the brain. As in, if you were to take a biopsy of other regions of the brain, you would probably find normal thiamine metabolism. But if you go to those specific cells, you find a defect in the utilization, defect in the transport, basically an intracellular thiamine deficiency. And therefore, how can you expect that to affect the systemic level of metabolites? You know, like you do an organic acids test. What that is measuring is the systemic level of metabolites that are filtered through your kidneys. So if you've got a total level of, like, one of the markers is pyruvate, another of the markers is lactate, another of the markers is alpha ketoglutarate, right? So those are like 3 markers that you might see high in someone who has thiamine deficiency. But if their total levels in the body are completely normal, and yet you have some region of the brain which displays this aberrant thiamine metabolism, do you think that that is going to have any effect on the systemic levels of the metabolites that you pee out? It's not, right? And this is what we see. So these kind of localized deficiencies have been identified in Huntington's disease, in Parkinson's disease, in the heart. So it can just occur in one single chamber or a collection of cells in the heart. It can occur in Alzheimer's disease. So a cerebral brain-based thiamine deficiency is considered by some to be one of the driving factors of Alzheimer's disease. Recently, there's been a $300 million clinical trial run on benfotiamine to treat Alzheimer's because of this cerebral deficiency. But this is the kind of thing that is not necessarily going to affect blood levels, urine levels, any of the metabolites these functional medicine tests check. So unless you can get a biopsy, somehow have the precision to measure, this one specific region of the brain or whatever, sometimes a lot of the conditions that respond to high-dose thiamine are simply not going to be identifiable on ordinary testing. And so to kind of come back and to talk about some of the conditions that do respond, again, we have to shift away our understanding and our perspective from a traditional kind of concept of deficiency more towards a mishandling or a misutilization, what I call a functional deficiency. And this can occur at the single cell level. It can occur at the tissue level and at the organ level. And it's very difficult to identify. We suspect it probably is happening in fibromyalgia because there are a subset of fibromyalgia patients who respond with almost 100% symptomatic improvement when they reach certain doses of thiamine. Same thing goes for Parkinson's disease. There are thousands of people who are symptom-free and are essentially in remission from Parkinson's, which is an incurable condition, simply using high doses of thiamine. It's usually dose dependent. But again, these people aren't deficient. But when you take them off thiamine, you see that their symptoms relapse. Similar thing, that they're actually trying it out in Huntington's disease because what they found is a very specific genetic mutation. It's called CRBEP, I think it is. Anyway, it's a transcript which codes or which is involved in in coding for a transport protein, which gets thiamine into a particular region in the brain, which is known to degenerate in Huntington's disease. So this most recent study, they essentially concluded that Huntington's was an intracellular thiamine deficiency in this small region of the brain. And if they could fix that, then they could potentially fix Huntington's. Now, what they found was it worked in mice and they're currently trialing it in humans. So we're going to see how that plays out. But really, any form of neurodegeneration appears to involve some kind of aberrant change in thiamine-dependent enzyme. But I want to be clear, when we're talking about a cerebral deficiency, or we're talking about a deficiency at the cellular level, we're not necessarily saying that the cells don't have enough thiamine, although it's possible that they don't. What we're saying is, to be more specific, there is an impairment of thiamine-dependent enzymes. Now, remember what I was saying before, is that it just so happens that the enzymes which are rate-limiting factors in energy metabolism are also the ones which are dependent on thiamine. And it kind of ties back to thiamine being this anti-stress molecule, which I believe it to be. I think it's quite unique, although that's my theory. But basically what we see is that the thiamine-dependent processes which are rate-limiting become blocked. Now, there's many things which can block thiamine-dependent enzymes, which are not just thiamine deficiency. So, okay, it's true. If you make someone deficient, if you give them a bunch of alcohol, if you make them severely deficient, those dependent enzymes will slow down and the rate of energy metabolism will also slow down. You'll get brain degeneration. However, someone can have normal levels of thiamine, but you can have a blockage of those enzymes by various other things. One of those is heavy metals. Another one is some of the toxins which are produced by bacterial or kind of protozoal infection. Other things include neuroinflammatory markers. So, you've got chemicals that are produced by neuroinflammation or by the immune cells in the brain, which actually block or they inhibit or they inactivate those thiamine-dependent enzymes. So you end up with this situation. You end up with the equivalent of a thiamine deficiency, even though the cells have enough thiamine, because other noxious factors inhibit the enzymes. So the end result is the same. Blockage of thiamine-dependent enzymes, whether it's because of a deficiency, dietary deficiency, or whether it's because of toxins or neuroinflammation or TBI or heavy metals, can have a similar consequence at the level of the brain. This is probably what's happening in something like Alzheimer's. It might be what's happening in Parkinson's disease. But here's where it gets interesting, because here's where the work of Dr. Victoria Bunick, she's a professor in Russia. What they've shown is that if you have blockage or inactivation of these enzymes, often what it does is it reduces the affinity for thiamine as a cofactor. However, what you can do is you can saturate those enzymes. If you saturate them with massive amounts of thiamine, whatever's been inactivating them becomes irrelevant, because you can reactivate those enzymes to start working again just by giving high doses. To give you an example, I'll send you this study as well. It's fascinating. Bunick and her colleagues at Moscow University, what they did was they exposed rats to traumatic brain injury. Then they measured their brains and they looked at the mechanism of injury. And one of the key mechanisms of injury, you probably understand this, is a depletion of cellular ATP. Because when you get the depletion of cellular ATP, this is one of the things that triggers neuroinflammation and all of the downstream effects of that. So in case people don't know, during traumatic brain injury, one of the main causes of damage to the brain is not the initial injury. It's actually the secondary injury caused by the brain being unable to turn off the inflammatory response. That's why getting there really quickly after TBI is super important, because if you can turn down the inflammatory response in the brain, there might not actually be that much brain damage. So interesting thing is that mitochondria are involved in that process of modulating the immune system. So what did they find? They found that one of the reasons why there was this massive neuroinflammation in the brain in these rats from TBI was because of this blockage on mitochondria. And which enzyme was it that caused the blockage? It was the inactivation of alpha-ketoglutarate dehydrogenase, which is that considered the rate-limiting enzyme in the mitochondria TCA cycle. And it is also, lo and behold, a thiamine-dependent enzyme. So they established this mechanism. They said, wow, okay, if we inhibit this enzyme because of TBI, then this causes major downstream effects and basically destroys this rat's brain. So what did they do in their next experiment? They gave a different set of mice massive doses of B1, okay, because it's a cofactor for alpha-ketoglutarate. They gave them massive doses of B1. They exposed them to the same TBI. What did they find? There was not the inactivation of that enzyme. In fact, the mitochondria continued to make ATP because the enzyme had been saturated with B1. And what did you also find? You found way less brain damage. There wasn't this massive neuroinflammatory cascade because the cells managed to maintain a state of energy flow, because they were saturated with B1. They did the same thing in spinal injury as well. So we can kind of attempt to extrapolate these results and say, well, saturating cells with high doses of this nutrient can potentially counteract this enzymatic inactivation and this disruption in bioenergetics by other causes. This was not caused by a nutritional deficiency, and yet using this nutrient as a medicine in high doses could effectively counteract that and maintain cellular bioenergetics. And that is how I think it might be working. And that is also why sometimes people require extremely high doses to see any benefit. So I suspect in some cases of chronic fatigue syndrome, fibromyalgia, other complex conditions, I suspect this kind of mechanism is at work, because what you'll find is that sometimes, you put someone on 200 milligrams, 300 milligrams, 400 milligrams, no change whatsoever. But as soon as they get up into the doses of like 800 to 1000 milligrams per day, it's like a light turns on and all of a sudden half of their symptoms disappear overnight. It's like, how can we explain this? I don't think it's addressing a deficiency in the conventional sense of the word. Sorry for that rant, but yeah.
No, it's a great explanation and helps to understand why testing is not particularly helpful. If you can have normal levels and still have issues, then obviously testing is not going to give us a full picture. I want to talk a little bit about people with high anion gaps. So the calculation of sodium plus potassium and subtracting the sum of chloride and carbon dioxide, that can be an indicator of metabolic acidosis or an imbalance in our pH, in our acid-base balance. Some have suggested that this can also be a clue for thiamine deficiency. Wondering if you can talk a little bit about the connection between lactic acidosis and thiamine deficiency.
Of course, yeah. So lactate is generated via a process called glycolysis. When you metabolize glucose, it's entered into a set of steps collectively referred to as glycolysis. And it generally, what we make from glucose is we break it down into molecules of pyruvate. Now, pyruvate, in the presence of oxygen, in the normal state of production of energy in the mitochondria, pyruvate is going to be transported, and then we're going to break that down even further to make large amounts of ATP. However, in the presence of either hypoxia, so when the cells don't have enough oxygen, or alternatively, in the presence of thiamine deficiency, the enzyme which is necessary for taking pyruvate and actually acting on it in the mitochondria, it's called pyruvate dehydrogenase, that requires thiamine. So that's one of the first enzymes to slow down in thiamine deficiency. And so what ends up happening is that you can no longer process glucose with oxygen. You end up rerouting pyruvate into lactate synthesis. And so one of the signs of a severe deficiency in the blood work, you will see lactic acidosis. So massive amounts of lactate are basically floating around in the blood, and your kidneys have to deal with that. Okay. So one of the reasons for a high anion gap in thiamine deficient lactic acidosis is because it's reflective of this metabolic acidosis caused by the massive amounts of lactate. At the same time, thiamine deficiency, even mild thiamine deficiency, you lose the ability to retain potassium at the level of the cell, and you can end up wasting that at the level of the kidney. So you're going to end up with a higher ratio of sodium to potassium in the blood. And there is some it's speculated that actually you can cause losses of bicarbonate as well. But essentially what is happening, I haven't personally seen that in many of the people who respond to it, but in severe deficiency, that's one of the reasons why you would see high anion gap.
Talk to us about how the various forms of thiamine or B1 are different. Talk to us a little bit about tolerated versus target dosages for thiamine hydrochloride, benfotiamine, TTFD, or thiamine tetrahydrofurfuryl disulfide. How low and slow do we need to go if we have a chronic illness when we're starting to incorporate thiamine? How well, in your observation, is it tolerated in sensitive patients? And is there kind of a laddering process whereby maybe we start with thiamine hydrochloride, work the dose up, later move to benfotiamine, work the dose up, maybe then to TTFD to increase our ability to tolerate the incorporation of B1?
Those forms, the derivatives, just so the listeners know, during the 1960s, Japanese wanted to figure out how to better get thiamine into the body because There are limitations of using normal thiamine hydrochloride. There are saturable transporters, and there's limited benefit in someone who's severely deficient. Oftentimes you would need to do IV, but they were trying to find ways to increase the bioavailability of thiamine. And so what they did was they synthesized lots of derivatives. So when we're talking about derivatives, we're talking about things like benfotiamine, sulbutamine, and TTFD, like you just mentioned. The difference between them is that benfotiamine has a specific chemical group and attached to the thiamine molecule. It's called an S-acyl derivative, whereas TTFD and sulbutamine have sulfur groups, or they're called mercaptans. Basically, it's a different chemical group attached, and it gives them kind of unique qualities. Now, both benfotiamine, sulbutamine, and TTFD can all penetrate the cell without the need for a transporter. This gives them fairly unique properties, and it means that they don't have the limitations that other cheaper forms of thiamine do have. And it means that they're very well able to get into the blood from the gut, to get into the cells from the blood, they get into the brain from the blood as well. There's not many limitations. Okay, so what I found is that the form that generally is going to be most effective, the lowest dose, is going to be either TTFD or sulbutamine, so the disulfide derivatives. I don't know why that is, but they appear to be quite effective anywhere from, and it really depends on each person, but general range would be anywhere from 200 to 500 milligrams per day. Now, with benfotiamine, on the other hand, oftentimes the range, it can be anywhere from 600 to 2,000 milligrams per day. With thiamine hydrochloride, which is the cheapest form, or thiamine mononitrate, sometimes the dose would need to be upwards of 1,000 to 2,000 to even 3,000 milligrams spread out throughout the day. Okay, so the salts, you need higher doses, much higher doses. Benfotiamine generally also requires higher doses. The disulfide derivatives tend to work at much lower doses. Some people only require a capsule, like 50 or 100 milligrams, and they're fine with it. So that's important to note. However, listeners also need to understand that just because they provide thiamine, the research suggests that they work in different ways. So they have ancillary effects that are not related to thiamine. For instance, benfotiamine is being studied in Alzheimer's, yet it doesn't appear to affect thiamine-dependent enzymes in the brain to the extent that you would think. It seems to be affecting gene expression. It's promoting the production of antioxidants. It's promoting the production of anti-inflammatory proteins. There's lots of different protein targets that these derivatives are affecting that haven't been well studied. The same goes for TTFD and sulbutamine. It's having effects not only to supply the cell with thiamine, but it's also having other effects that haven't yet been well characterized, but do appear to affect gene expression, affect the redox status of the cell, whatnot. So they are not equivalent to taking high doses of thiamine hydrochloride. And oftentimes you will find people that require the derivatives. They do not benefit solely from thiamine. And that's because it's not just having a metabolic action. It's probably acting on protein targets and things.
So do you recommend when people are first starting to use this that maybe from a tolerance perspective that maybe they start with thiamine hydrochloride and then move into the derivatives? Or do you think that some people, even more sensitive chronic illness type community, can start with TTFD but start low and work up slowly? How do we maximize tolerance of the introduction of B1?
Yeah, okay. So in the average person, they can start with derivatives, usually if they're just dealing with digestive issues, if they're dealing with just some neuropathy or some fatigue or something like that. If you're dealing with any kind of complex chronic illness, which I'd imagine like are going to be a bunch of people that are listening to this, generally it's best to start with a non-bioavailable form, so not a derivative. It's best to start with thiamine hydrochloride or mononitrate. And some people require very, very, very low doses. And really, this is not the form that is going to have any major effect on their physiology. It's almost like reintroducing a substance and getting the body kind of prepped for tolerating it. It's first is to assess tolerance, but it's also to kind of send a signal to the body of abundant thiamine. It's almost like the body needs time to recognize that and put the things in place so that it can start dealing with higher doses. I'm not sure the exact mechanism, but that seems to be the case. So you may want to go as low. I've had some people go as low as like 1 milligram of thiamine hydrochloride. But most people would want to start at, say, 500 to 100 milligrams, get their body used to it, and then gradually build up over time based on tolerance. So, I mean, they do also need to know is the paradoxical effect. This is not very well characterized in the literature. No one really understands why this happens, but there are some theories. What this basically means is that you can experience a worsening of some symptoms when you start thiamine therapy. This does generally reside within a couple of days. The key is to go very low and slow, particularly if you're sensitive. So you would increase by maybe 50 milligrams per week, some people every couple of days. And as you get to, say, 300 to 400 milligrams of thiamine hydrochloride, that's when you would want to start trying a thiamine derivative. And which derivative you choose is going to depend on what your main problem is. So, for instance, if your problem is POTS, if your problem is severe digestive issues, you would want to start with TTFD. If, on the other hand, your issue is fibromyalgia or neuropathy or something like that, you would want to start with benfotiamine. So it comes down to those different properties, which derivative you would start with.
So let's talk a little bit more about those paradoxical reactions. I know Dr. Chandler Mars has talked about some connection to glutathione, also to methylation. So talk to us about how we implement strategies or approaches to minimize these paradoxical reactions. So how often do you see people being unable to tolerate the exact B vitamin that their body so desperately needs?
Yeah, maybe 5 times out of 10. So 1 out of every 2 people will experience a paradoxical effect, and it generally correlates with how ill they are. And now it's paradoxical because you would think that if your body is crying out for something, then you would have a positive response to it. And it's ironic that a lot of the people who try thiamine get such a severe response. They usually try too high of a dose too early. They get such a severe response, and they're actually scared away from doing it when it's in fact the one thing their body needs so much. So no one knows exactly why this is. As I said, there's theories, but the paradoxical effect is generally going to present. I mean, the typical symptoms are going to range anywhere from pain, head pressure, fatigue, lethargy, sleepiness. Those are the most common ones. However, what you can see is a recurrence or a worsening of your main presenting symptom, which stems from a lack of thiamine to begin with. So it can be that your digestive system starts to change. For instance, if you have hypochlorhydria, you can actually see either a worsening of hypochlorhydria, or you can see that you get excess acid in the stomach. Now, again, this hasn't been documented in the Western literature, but in the very early reports of treating beriberi in Japan, they found that there were these characteristic changes in symptoms, and it could take anywhere from a month to 2 months of people experiencing these odd symptomatic changes, either a worsening of what they've got or the opposite of what they've got. Like, for instance, if they have bradycardia, low heart rate, they could have high heart rate, or they could have a worsening of low heart rate. Likewise, if they have constipation, they might develop diarrhea. Then it might fluctuate to constipation again. Then it might go to diarrhea again before it normalizes. So anything that you have, it could either be pushed in the one direction or pushed in the other direction. Probably because the autonomic nervous system starts firing again, and sometimes it can be excessive, sometimes it can be too minimal. It's kind of like there were lots of reasons why this might be occurring, but as the nervous system starts coming back online, it can be a bit treacherous. It can be up. There's lots of ups and downs when it comes to symptoms. The main way that appears to work to deal with this is to make sure that other nutrients are on board. Now, the reason I say this is because, again, like your listeners probably understand, when you give a high dose of any one nutrient, you're potentially throwing out other nutrients as well. You think the body is one big machine and all of your enzymes are like little cogs, interrelated cogs. When you move one cog, you give a massive dose of one nutrient, you move one cog, has knock-on effects on all those other cogs. What that does is it potentially increases the demand. And mechanistically, that was very oversimplistic, but mechanistically, you could also justify that. It increases the demand for other nutrients which are involved in those processes. So what you often see is when you start supplying B1, you see an increased need for magnesium. You see an increased need for potassium in particular. So magnesium, potassium, really, really, really important. Secondly, riboflavin, vitamin B2. Oftentimes, you see that there are signs of deficiency of someone who takes high dose B1. They develop riboflavin deficiency signs. It means that they They might start feeling fatigued, but they might also develop a rash on the face, for instance, and chapped lips. They take riboflavin and it disappears. So it's not that B1 is depleting those other nutrients. It means that as your energy systems are starting to come back online, you're unmasking other deficiencies, or you're increasing the demand for other nutrients. So the key is you want to be replacing electrolytes at the very least, probably a higher dose of magnesium, anywhere from 300 to 400 milligrams per day, a good overall electrolyte, and a good overall B complex. Now, that's not to say that other nutrients can't be needed in higher amounts, but a good solid B complex should hit most of those bases. And the key is to start very low and slow and work up very gradually. Now, with the other derivatives, there can be some other interactions. For instance, some people who do not tolerate TTFD, it might be reflective of poor redox status at the cellular level. So it might be that they're oxidized to reduce glutathione is not good. And therefore, because of the biochemistry of TTFD, it can potentially worsen that scenario. Now, what some people find is that if they don't tolerate TTFD, taking some liposomal glutathione or some glutathione precursors like glycine, glutamine, NAC, these kind of things can very much help in allowing someone to tolerate that, but it's highly individual for sure.
So you mentioned that TTFD does have this sulfur component as well. Is there a scenario where TTFD may be better tolerated if someone's also using molybdenum to improve their ability to tolerate sulfur?
Oh, it definitely seems to be the case. Yeah, without doubt. So the sulfur, you see, all thiamine molecules contain sulfur, but to be very clear, the sulfur is always contained within that thiamine molecule. It's never unbound, it's part of its molecular structure. The difference with TTFD is that it actually has an added sulfur group, and that's part of the reason why TTFD can be so beneficial. So that sulfur group there was literally a study just came out like 2 weeks ago looking at that sulfur group, and it was showing that has very potent antioxidant effects, and it can increase, it like triggers NRF2, it increases the cell's production of its own antioxidants, but also its protection against other toxins. So it's having these kind of ancillary effects. When it gets into the cell, it detaches the thiamine from this sulfur group, but it means that the sulfur group in the thiamine essentially allows thiamine to dissolve in massive amounts into cells. Now, the problem is that some people who have very problematic metabolism of sulfur, sometimes it can help them because you provide a source of kind of sulfur, and that extra group is metabolized in various ways, and it does lead to production of inorganic sulfate. But as part of those pathways, it seems as though it also leads to production of sulfite. Now, we know that molybdenum is very important for the detoxification of sulfite. And so anecdotally, many people report that taking molybdenum with TTFD can help them deal with the potential side effects of TTFD. Now, I find probably 7 out of 10 people don't have any of those issues, but in those very sensitive individuals, molybdenum can very much help tolerate TTFD.
Is there a maximum period of time that someone would incorporate B1 into their protocol? And does the dosage potentially go down over time as any deficiency is repleted? We know it could be more than deficiency based on your earlier comments. Or once someone gets to a dose that really makes a difference in their symptoms, do they need to stay at that dose indefinitely?
Yeah, that's an excellent question. It really needs to be assessed on a case-by-case basis. As a general rule, you want to determine if someone is deficient or dependent. When I say dependent, we're looking at those highly complex conditions, neurodegeneration. There's a good chance that these people may require it long-term, potentially for the rest of their life, because the thiamine is not necessarily, it's not a deficiency that's causing it. And so until you address what's actually causing it, you don't know. Now, that said, there are some people with Parkinson's who manage to start at a very high dose. They achieve like almost remission, and then they wean down the dose and they just take it every couple of days. They seem to be okay. Really, the way to answer those questions is to trial it out. And that's what I do in relation, like you said, do I test people? No, I learned the best way to do it is to gradually titrate up the dose. If they fit the symptoms, you titrate up the dose. And the general recommendation is you want to titrate up the dose gradually until you see significant symptom improvement. So in my document, my PDF, I take you through, there's a diagram. Every time you increase the dose, this is based on Lonsdale's 60 years in clinical practice. He was the guy who figured this out. What he figured out was the best way to optimally manage the paradoxical effect and to find out the perfect dose is you would start at a low dose and then you'd increase until you notice any change in symptoms. It can be worse or it can be better. Any change in symptoms whatsoever, you stay at that dose. You stay at that dose until that change in symptoms returns back to baseline. So for instance, if you notice an increase in fatigue or lethargy or anything like that, then you remain there. You do not increase, but you continue taking that dose until it returns back to baseline. And only then do you increase the dose again. Now, for some people, they don't get any paradoxical effects. So I would say for those, just keep on increasing the dose and watching out for symptoms. Now, some people find a complete resolution of fatigue or dysautonomia, say it's at 600 milligrams. I would say you don't need to increase it. You can try and increase it. Some people try and increase it, but then they might experience like negative symptoms. So actually they come back down, find the sweet spot dose, and you just stay there. You stay there. I would say a safe time to stay there is anywhere from like a month to 2 months or 3 months. And then you start to wean down. If you see that your symptoms start coming back, you know that you need to stay on that dose for longer. Now, it can be that some people need it for 6 months, a year, 2 years, okay? But then they can gradually start weaning down. So the key is you use symptoms as your guide. If you notice a worsening when you reduce the dose, then it means that you need that higher dose. But one other caveat here is that what some people find is they find their sweet spot after a month, and then they start noticing all of these strange symptoms start coming on. They increase the dose, the symptoms even get worse. Now, that could be the opposite problem. That can actually be that they're overloading their system with too much thiamine, and that actually they were at that dose. They don't need it any longer. And when they start to reduce, they start seeing that their symptoms start to improve again. So it can go either way. And really, the only metric that you should be using is someone's symptomatic responses to each different dose.
Question from a listener: what is the connection between TPK1 variants or thiamine pyrophosphokinases 1 and chronic thiamine deficiency?
Yeah, well, I believe there's a condition called Amish encephalopathy, and I think that this is the one that involves the mutation in TPK. TPK is basically the enzyme which activates thiamine into active thiamine. When you absorb it into the cells, you absorb it as just plain free thiamine. Even if you take TTFD, you would get it as free thiamine. And then you need to run it through this enzyme to basically process it, to activate it so that it can then be used in biochemistry. Now, if you have a TPK variant, it's unknown how common that is, how relevant it is clinically. I think it's highly likely that most of those have not been well characterized. They still find new ones every single day. Every day, that's an over exaggeration, but it's very frequent that they find these variants. If you have a variant that is a pathological variant, then it's possible that you're not going to be able to activate thiamine. And so you're going to be ending up with this kind of pathological thiamine deficiency. What I can say is that a lot of these variants, it's a key factor, a lot of these variants, what it means is that they still work, but they may work at like 20% their efficiency because they have lower affinity for cofactor. What does that mean? It means that theoretically, some of them, if you saturate the cells with high amounts, you can speed up the way that enzyme works to normal levels, okay, by giving massive doses of thiamine. So it's theoretically possible that even if people do have these kinds of variants, which I think probably many of the people who do respond do have them, and they become pathological for whatever reason, if they do have them, by giving high doses, you may be able to stimulate the activity to normalize.
Many of our listeners are dealing with CIRS or chronic inflammatory response syndrome. Biotoxin illness can be from mold, mycotoxins, actinobacteria, endotoxins, Lyme, co-infections, many factors. How do you view the role of thiamine in supporting those dealing with biotoxin illness?
Yeah, it's a double-edged sword. Honestly. That's what I found. It's like one of the main exceptions because, I mean, you'd mentioned prior, this concept of the cell danger response. Now, thiamine can potentially work wonders in these patients, or it can make them feel 10 times worse. Much like many other supplements can make them feel worse. It's not unique in its ability to make people feel worse, but it's that it's stimulating mitochondrial function. And if someone is in a situation where their cells, maybe they're stuck in like CD1 or whatever, I'm not an expert on this, but you understand what I'm talking about. If their mitochondria are not geared up or not optimized for making energy, and it's not necessarily beneficial to make energy in that moment for whatever reason, because it's under threat, then providing thiamine may make symptoms worse. You may be generating high amounts of oxidative or free radicals and whatnot. And that does play out in real life. That said, it can also have the opposite effect, and it can help to restore nervous system function in these patients. I guess it just depends where they are and what else is going on with their physiology. I have found it to be very effective in people who are trying to re-regulate their nervous system, particularly people who are using like DNRS and other limbic system retraining, trying to find ways to potentiate the vagus nerve, because there does seem to be this connection between, the cells stuck in the cell danger response and then the action of the vagus nerve to actually send a signal to readdress and actually calm down that kind of danger threat or whatever it is. Because thiamine helps with that system, it does seem to do that in some patients as well. Really, the only way to know is to trial it out. It's like 50-50 in those individuals. Some people, it kind of brings them completely out of what you would call, or what, say people have been diagnosed with SIRS, whether they get post-Lyme syndrome or whatever, and they've done all these therapies and they're not fully there. They're still there's still lingering issues. Sometimes thiamine can completely bring them out of that. Sometimes it can make them feel worse. So the only way to know is to trial it.
Earlier this year, you shared that you had done a provoked urine test and had high levels of lead. Wondering if you know where the lead came from. Your personal plan at that point was to use oral EDTA, to do saunas with niacin, to incorporate other nutrients such as your thiamega, thiavite, which we're going to talk a little more about in the next few minutes, alpha lipoic acid. You worked on supporting your liver with glutathione support, S-acetylglutathione, augmented NAC, vitamin C, glycine. For phase 3, you talked about PC and TUDCA. You also incorporated some electrolytes with Thiacyst, and then incorporated activated charcoal and modified citrus pectin as binders. Listeners are wondering how your protocol went and if you've done any retesting, and then maybe also connect that to, is there a role of thiamine in the lead detoxification conversation?
Yeah, okay. I've been meaning to retest. I've been doing it. I've not been doing it as strictly as I said in that video, because I realized after the video that I set very high standards for myself, and then I realized, okay, this isn't actually possible. So what I would have liked to take 6 months, I am thinking that it's doing it. I'm spreading out. I'm doing it over a longer period of time and less intensively. Yeah, simply because of a time management thing. I came to the conclusion that actually I tried to do it for a couple of days or for a couple of weeks actually, and I realized I couldn't spend upwards of an hour in the sauna every single day. I just didn't have the time. I couldn't be doing like this exercise, doing all these supplements every single day and all the other stuff. So I've decided to spread it out, and I'm going to be doing it over a longer period of time. The idea is just to support my body in the best way to get rid of whatever I have. I know that EDTA is also not specific for lead. It has mild kind of chelating abilities for other metals as well. So I'm a big fan of that molecule in particular. How's that going? Yeah, it's going slower than I originally said in the video. I will retest. I'm not sure when, maybe in a couple of months, but I'm doing it in a more spread out fashion.
I mean, at the end of the day, I think, unfortunately, given the world we live in, detoxification, including of heavy metals, but also pesticides, chemicals, all of those things, I think it's daily and lifelong. Yeah. I don't think it's a short-term detox and then we just move on and don't reacquire these things. There is a connection between heavy metal toxicity and people's level of EMF sensitivity. So listener asked what your latest thoughts are about EMF sensitivity, and does thiamine play a role in those that are EMF hypersensitive?
Yeah, for sure. In some people, thiamine can completely address the EMF hypersensitivity. And I think it comes down to excitotoxicity of neurons. It would seem as though, EMF affects everyone's brain. That's the fact, though essentially the vast majority of people just don't feel it. So there's a difference. And I think the most convincing theory that I've come across is Martin Poole's concept of kind of like a neural hypersensitivity, where there's this lower threshold for excitotoxicity in neurons. And this occurs not only with EMF hypersensitivity, but also appears to apply to multiple chemical sensitivities as well, is that it's essentially a central nervous system disorder. Now, if you look at what happens to cells when they don't have enough B1, well, they end up, without going into the details, they can't uptake glutamate. You end up with high levels of glutamate in the extracellular space. Glutamate transporters for being uptaken into cells decrease, and so you end up with this massive amount of like synaptic glutamate, which end up firing neurons. And that's what I think EMF sensitivity fundamentally is firing neurons excessively when the ordinary person has a higher threshold for that, probably because they can mop up glutamate and all this kind of stuff. Now, that's, again, vast oversimplification, but thiamine can help, probably because it's helping metabolize excess glutamate and increasing what I suspect is the threshold for excitotoxicity.
So our last couple of minutes together, I want to talk a little bit about your company Objective Nutrients, some of the products that you've created, Thiamax, Thiamega, Thiavite B Complex, Thiactive B, and Thiassist. Talk to us a little bit about the products in your line and the application of those products.
Yeah, okay. So it was 2019 where I saw an opening in the market. Essentially, the main reason why I made it was because we couldn't get TTFD in the UK from a reliable supplier. It was very difficult. And I tried to find ways to wholesale, but that wasn't possible. And I'd also found that when you could get it, a lot of my clients, particularly, SIRS type clients and people who have high sensitivities, they are reactive to fillers, excipients, and they're very strict about what they can and can't use. And so I was kind of left with this scenario where I really wanted to recommend TTFD, which I'd found to be so helpful in people with like chronic gut issues, but my clients were refusing because the only single brand that made it at that point would use excipients. And so it's kind of, I had my back to the wall and I decided, well, the only way that I can physically do this to provide this to people is by manufacturing my own. So we manufacture Thiamax. Thiamax is basically just TTFD. It contains a small amount of magnesium taurate to basically fill out the capsule. It's the smallest capsule size that we can physically use. The idea is that we don't use any excipients. And from that, a little did I know that that would actually go on to be really popular. And then I decided, well, in fact, there's lots of supplements that I'd like to see, but no other company is making. So why don't I just make it myself? And that's how it kind of just grew into this thing that I never thought it would be. I never really determined to make a supplement company. It just kind of happened. And I was like, you know what? I'd really like to see this. No one's done this. So I decided to make Thiactive B. And Thiactive B is it's a B complex, which has a low amount of B6. A lot of my clients, they're very sensitive to B6. So it contains a high amount of riboflavin. Riboflavin is involved in the activation, the utilization of B6, but it contains a low amount of B6. At the same time, it contains two types of thiamine. It contains a small amount of TTFD and a 50 milligrams of benfotiamine. So that means someone, if they're very sensitive, they don't have to take thiamine. They could just take one single B complex capsule or half a capsule, and that's a way for them to start like testing their sensitivity to the different derivatives. All of it was really born out of the stuff that I was recommending to my clients and using, but instead of recommending, buy these 4 supplements, it's like putting them into one, So, and that's what all of our products are around. It's basically my work on thiamine and dosing thiamine and high dose thiamine. Now, you mentioned Thiavite. Thiavite is another one. It's another one that doesn't contain methylated folate and B12. And as you know, a lot of people, especially the whole cell danger response stuff, can really send them in a bad way, taking methylated nutrients. So the idea behind Thiavite is a similar concept to Thiactive B, but again, what we're doing is providing adenosylcobalamin and calcium folinic acid, not folic acid, but folinic acid. And same thing with Thiassist. Thiassist is kind of like an alternative to having to buy potassium, magnesium, selenium, the things which can help the body utilize B1 when they're going through these paradoxical reactions. The idea was to provide everything into one package. And we've recently kind of branched out. I formulated 2 new gut products because, in fact, many of the people who are on my protocols, they use my protocols. I do recommend gut-specific supplements. So I'll say, use serum-derived immunoglobulin, use lactoferrin, use sodium butyrate. As you're trying to deal with using thiamine to promote the autonomic nervous system in the gut, it helps to have things which can seal up intestinal permeability, which can rebalance the microbiome, all that kind of stuff. So I decided, well, actually, I'll formulate these 2 new products. There's like 8 products in one or 8 products in 2, rather than getting people to buy all these products. It's like just stick them into 2 different ones. It's really just about utility, you know? It's just about what I want to see on the market that no one's done. So it's just like, well, why don't I just do it myself?
So the 2 new products, that's your Gut Max and Better GI. So how do you distinguish or differentiate those 2?
So how you distinguish between the 2? Okay, so Gut Max is basically a encapsulated, and it's in enteric capsules, and it's a combination of sodium butyrate and actually quite a low dose. We couldn't fit any more in the capsule, but the thing is that I found sometimes when people take higher doses of sodium butyrate, it can actually trigger diarrhea. So I like to use a lower dose, because lower doses do seem to have beneficial effects in the literature. So it's quite a low dose, like 300 milligrams. Lactoferrin, which is an immune protein, which is remarkably effective for sealing up the intestinal barrier and improving the immune system in the gut. And then the other ingredient is Saccharomyces boulardii. Saccharomyces boulardii, as you know, it's a transient yeast. It doesn't colonize the gut. But what it's been found to do is that Saccharomyces boulardii can help the colonization of other so-called beneficial microbes. And it's particularly good at reducing, if you've got any kind of infection. It's actually used for infectious diarrhea, but if you have any kind of a gut infection, that can help kind of neutralize or counteract the immune response caused by that infection. So I find it very interesting, and I find it to be very effective. So that's the one product. Second product is that's a powder, and that is serum-derived immunoglobulin, which you probably know about. There's lots of companies that make it, and it is essentially an alternative to colostrum, but it's not it's a non-dairy alternative. It's similar profile, so it's just made up of massive amounts of immunoglobulins, which are immune cells, and you think of it a little bit like antiseptic paint along the GI system. So it can bind with, it's like very similar to the immune cells that your gut makes, bacterial toxins, bacteria, fungi. It can actually bind with those, not only prevent them from getting across the gut barrier, but actually carry them out of the gut as well. So if you're dealing with any kind of a difficult gut infection, say you start using thiamine to increase motility, it really helps if you do have something which does possess some kind of an antimicrobial action, which isn't going to like decimate your entire microbiome. So serum-derived immunoglobulin is really useful for that. Another one is N-acetyl-glucosamine, which is, you think of it like a glue that your body will use then to incorporate, or to basically use as a building block to seal up the intestinal barrier. And another one is zinc carnosine. And zinc carnosine, as you probably know, is long use in gut issues. And really, there's nothing so unique about these products. It's just that, to get all of them, you would need to buy a total of 6 different supplements, and that can be really expensive. And a lot of people just don't want to buy 6 and then remember to take 6 different things, as is like, well, because compliance is really bad among people like that. Why not just combine them all together and make it so that it's much easier to take in kind of as an affordable way as possible? So that was the philosophy behind it.
Awesome. Yeah, I think I'm very excited to see what you guys continue to do, and happy to have the tools and products that you've already brought to the market. My last question is the same for every guest, and that is, what are some of the key things you do on a daily basis in support of your own health?
I would say recently, I wouldn't recommend people to do what I've been doing to support my own health, because I tend to get a little bit one-track minded when I'm working on a product and stay up late. I think ideally, my optimal scenario would be to maintain a robust circadian rhythm, ideally with the light cycles. I know that I feel my best when I do that, although I'm not currently doing that. So eat as minimally processed diet as possible, ideally as local as possible, and undertake or try and implement a regular detoxification regime, whatever that is, whether that is infrared sauna, whether that is getting extremely sweaty with exercise, whether it is using some kind of a natural supplement which can help carry out toxins from the body, any combination of those things. That I just feel as though that is one of the most essential things. And finally, I of course take my own supplements, but I think taking a multi-nutrient is one of the best protection that you can have long term against against anything which robs you of your nutrition, because you have to understand that even though you may eat the best diet in the world, your environment is actively robbing you of nutrients. And that's not physically robbing you, but it's increasing your demand. And so providing extra in any kind of a multivitamin, multi-nutrient, I feel is just really good insurance. And it's something that I will continue to do probably for the foreseeable future until I die, as long as I've got access to it.
This has been such an incredible conversation. I appreciate your passion. It's super obvious. You're super generous with your time. Either people listening 2 hours, or if they're at half speed, like many of us probably were, maybe it's 4 hours and listening to you and all the great information. But so good. I think the education that you're putting out is really changing lives. I think your products are changing lives. I just really want to honor you and your work. And I think you're incredible. So thanks so much, Elliot.
Thanks so much for having me on. It was really great, Scott.
To learn more about today's guest, visit eonutrition.co.uk. That's EO as in Elliot Overton, nutrition.co.uk. eonutrition.co.uk. Thanks so much for listening to today's episode. If you're enjoying the podcast, please leave a positive rating or review, as doing so will help the show reach a broader audience. To support the show, visit betterhealthguy.com/donate. To get my newsletter, visit betterhealthguy.com/newsletters. To follow me on Facebook, Instagram, X, or TikTok, you can find me there as Better Health Guy. This and other episodes can be found on Apple Podcasts, Spotify, Amazon Music, YouTube, and Odyssey.
Thanks for listening to this Better Health Guy blogcast with Scott, your Better Health Guy. To check out additional shows and learn more about Scott's personal journey to better health, please visit betterhealthguy.com.